hope everyone is enjoying all the wonderful sessions here. And we have saved the best one for the last. Yes. All right. I'm assuming you can hear me loud and clear. So I'm Monica Chamboli. I'm System Verification Test Lead for IBM. I work at IBM with my colleague.
I'm Daniel Guinan. Can you hear me as well? Okay, great. I work with Monica on SBT.
So today's project is inspiration from attending one of the conference sessions a year ago or so. I attended on DevOps and I was curious. I went back and gave it a try, and it seemed promising for what we were doing. And I started to explore and create some tasks, and Daniel, my teammate, he started picking it up, implementing it, and we had a proof of concept which we shared with our team, and they were excited about it, and we implemented this, and it has tremendously helped us in gaining productivity with what we do. So we'll talk about this project today. We already saw that some of you are aware of DevOps. So people who are using DevOps, are you using Argo, Flux? Argo, okay. So we'll talk about more as we go along. So we have full agenda. We'll talk with So as I said, I work for system verification test. Before we talk about the project and how we implemented DevOps, I wanted to talk a little bit about what we do. So our goal is to test products like OpenLiberty is an open source, very lightweight Java runtime, which is perfect for cloud-native applications, running containerized applications. So we need to test OpenLiberty and as well as the commercial version, WebsterLiberty. And we have a bunch of operators to make it easier to deploy applications to Kubernetes. So we are supposed to run those as well. So how do you test some of these things? Runtime is you write applications. So in SVT, so we do develop, deploy, upgrade our applications as our customers would do. And these applications include homegrown as well as open source applications like JTrader, Acme, and these applications will need some prereqs like DB2 or MongoDB. And also, to act like customer, we want to stress these applications, so we use other dependencies like JMeter to run stress on these applications. Also, we act like any other, or like we have application owners who are developers, and also testers who are like more operations team who they don't necessarily know about those applications. Their job is to take it, run it, deploy it, and also we have clusters which we call them like production-like clusters, which we keep for a long time, upgrade the Kubernetes version or OpenShift versions, and make this automation was to reduce setup time for all the applications we have, quickly debug issues when they arise, and also manage this production-like cluster in cases where we have like continuous delivery, and also if something has to happen to that cluster, we can quickly recover that. So this is an example workflow, like manual workflow. I talked about different applications. So this is taking an example of JTrader. On the left is manual workflow. You can see, like, for a person who is not very familiar with the app, it can take up to 2 to 4 days, starting with building the application, creating container image, pushing it to registry, and then deploying the prereq like DB2, then deploying it to OpenShift or Kubernetes cluster, and then running the stress again. A new person have to write new scripts for the stress, and all those things involve time, and then debugging those. So on the right is what we are going to talk, the automated workflow using GitOps. So with that, we could really run the same thing within minutes, if not hours, depending on the expertise of the person. So go over a little bit technical overview of the GitOps. So I'd like to start I see a lot of people are somewhere here where they are already invested in infrastructure as a code, where you have written your configuration in YAML files, and you probably stored it in Git and their version control. And I have seen people using this in two ways. Either they do kubectl on those configuration files from their local laptop, or they are using some kind of CI/CD and run Jenkins job to source those files. So what are the issues with this? So the first one, let's say you have deployed your applications. Now someone goes to the cluster and make a change there to the cluster. Now you have configuration drift from what you originally had in your script. Second problem, there is no review process. Like, yeah, you change your configuration file, but there is no enforcement. Are we creating a PR? Are we reviewing it? Are we testing it before deploying? And also, you need credentials to your Kubernetes cluster as well, whoever is running that. So so what is GitOps? So it's like, yes, you need your infrastructure as a code. You have already invested time to write your YAML files for everything you want to do. Plus, you want to use best practices you have already been using for your applications, which is creating a PR, getting it reviewed, then running some tests. Other most important thing is using Git as a single source of truth. So what that means is, if you look at that picture there, that your Kubernetes cluster in this case is always in sync with what you have in Git. So it's constantly in sync both. So if you made a change in your Git repository, if you really want to say, let's say you want to change your CPU and memory constraints for your application, which is deployed on Kubernetes, you will really go to Git repo, make that change, and it will get replicated to the Kubernetes cluster. But how does that happen? You need some kind of agent on, there could be different ways, but one way is you have an agent sitting on your Kubernetes cluster. In this case, we have Argo, but there could be Flux, like there are other ones, but Argo and Flux being the most popular ones. We chose to use Argo because on OpenShift, they have OpenShift GitOps operator based on Argo. So in this case, the goal of Argo is just constantly monitoring and comparing actual state of the cluster to the desired state which is in the Git. So as soon as you make a change to Git repository, Argo will, depending on how you have set up your Argo, you could have auto sync enabled or not. So it will show you the drift. Like, yes, you have drift, so you can sync it again, or if you have auto sync, it will just go ahead and make that change to the Kubernetes cluster. So here is how our CI/CD flow looks like. This is our continuous deployment flow. So if we want to make a change to any of the application deployed to the cluster, you will make a change in this GitHub repository, and here Argo will make that change, and now we have a cluster which have the desired state we want. And of course, for that to happen, we have a CI where we are using Travis, where app developer, if they make a change, Travis will build the application, build the container image, push it to the Artifactory, which is being used by the deployment layer. Right? I think I'll now have Dan go through the implementation details.
Yeah, thank you, Monica. So, as someone who was new just about 2 years ago to the team, this manual workflow, it was a lot to learn. There was a huge learning curve, and learning our 10 or so apps that proved to be quite difficult. So we started with our GitOps journey just with a simple app deployment as a proof of concept. We installed the Red Hat OpenShift GitOps operator, gave it permissions to deploy. We created a Git repository where we stuck all our deployment files. And then we created an Argo application, which entails pointing it to the Git repository and then the exact directory where the deployment files are. Then once we had that, we thought, hey, this works really well. How can we expand this to make things easier for us? So we decided to add DB2, which is just a database dependency that our apps need, and JMeter, which we use to run stress. This wasn't a simple task in and of itself because pre-GitOps, we had these just running on VMs. So we had to first containerize these, which is quite an important thing to do, and GitOps pushed us to do that. We created common container images containing scripts. So we had a DB2 container that had scripts for restoring the database for all our apps, and then as well as JMeter, which had scripts to run stress against all of our apps. And keep in mind for these, order of deployment is very important. Obviously, you need your database running before you start your app, and you can only run stress after the database and the app are up. Now with Argo, we're able to achieve this order of deployment with their waves feature. So Argo, you add annotations to your resources, which determines the wave. So let's say we have wave 1, obviously in Kubernetes, you need a namespace before you do anything. Once you have that and it sees it's ready to go, it goes on to wave 2. So we have that as role bindings. Once those are on the cluster, ready to go, it goes on to the operator install. Once that's ready, on to DB2. Once that's ready, the app, and finally JMeter. Now, before I go any further, let me show a demo of this.
Maybe we go for sure.
Yep. So first, this is just for those who aren't familiar, the OpenShift console. We just install it by going to the operator hub. There's Argo CD operator, Flux operator, OpenShift GitOps. And if you're just on Kubernetes, it's a simple install as well. There's home charts, pretty straightforward. Then once you have that installed, Argo CD gives you this nice little console view of your running applications. And in essence of time, I decided to deploy these beforehand. And let's go through the process of creating a new app. Here you can just click, as you saw, new app in the top left. What you want to name it, let's call this one the Creator 7 project, this being the Argo grouping. Sync policy, we're going to keep that at manual for now, but you could have it to automatic. These are just more various options. And then source, this is the important part. So it asks you for a repository URL. The one we're going to use is our GitOps repo, which here, as you can see, there's a bunch of different app names. Those are just our apps, our SPT apps, each one with different features. And to deploy one, what you would do is go into the folder. You see here are just different flavors. So one sample, one just transactions, different flavors essentially. And here's the platform we have it deployed on. So let's say we want DayTrader 7 sample on what's your Liberty. So let's go back here. We're going to copy that. So here, repository URL. Okay, and then this is the branch we want. So you can point to different branches. And then it's nice enough to populate the paths for us as well. So DayTrader 7 sample, Webster Liberty, destination, and then we just want locally. And then we're ready to go. And I already have this one deployed, so I'm not going to hit create. The important thing to show as well is when we're creating this in the UI, you really only have to do that once, or not at all if you really want. But it creates a YAML for you that you could just save this somewhere on your laptop or VM and just deploy that, and it'll be deployed right away. So once we have that, we can go into our application. It has this nice little tree. Right. Maybe a bit off, but you can see it has a little tree of the resources. So this one's healthy, everything's synced up, good to go. Now, let's say we want to make a change. Our application's struggling on the memory-wise or CPU. So let's go into our GitOps repo. We have our deployment right here. So we have down here, let's see. Okay, so 350 CPU. Let's change that to 400. Maybe it just needs a little bit more. Now we're going to go down here. And normally don't do this, obviously, but I'm committing directly to me. I look dangerously. Okay, now that we have that, Argo pulls once every 3 minutes, but in this case, we're just going to hit refresh. Okay, now it sees it's out of sync, and it lists the commit number, and we can go here, click on. There we go. So the difference, that was Kubernetes stuff, but the remaining part, you can see the difference. There it is.
This is the configuration drift we talked about, right?
Yeah.
You can see the.
So you can see how the current state, which is on the left, is not matching the desired state. So to do this, if we add auto sync, it will fix it for us without any user intervention. In this case, we'll just hit sync. And then in just a few seconds, it'll say sync, and we can see the change. And another interesting feature of Argo as well is you can see the history of the commits and say someone pushed breaking code and that person was also me. I can just go in, quite easily roll back. So it's quite useful for not only configuration drift, but recovery as well, should something happen. Yep, so right here, sync okay, healthy, everything's good to go.
And we have heard that Flux does not have that pretty UI which Argo has. I don't know if they have caught up to that or not, but they do. They do know. We are behind, yeah.
So a little more details about the repo here. I briefly went through it, but it's pretty much as such. We have our GitHub repo, and then the application, and then the platform we want. So Open Liberty, which is the open source version, or WebSphere Liberty, which is the paid version. You would point Argo to the path, so Day 7 Open Liberty. Argo would read all of those deployment files in there, respecting the wave and such that we annotated in there, and it would deploy it to your cluster. Now, as our project grew bigger, we encountered an issue where we were throwing all of our YAMLs in this repo. There was a lot of duplication. A lot of these files in red, these are exactly the same, and it was a maintenance nightmare. We would have to, if we changed one of the files, we'd have to go through all of these subdirectories to do it. It was a problem. So we then solved this problem using Customize. So for those of you who haven't heard of Customize, it's a template-free way to customize applications based on patching. Similar purpose to Helm, just template-free. And it's also natively built into kubectl. So kubectl-k, and you use it. How do we use Customize? So very basic of Customize is you create a YAML, a customization.yaml, which tells Argo, kubectl, Customize. It tells it that, hey, this is a customized application. And you put the name of it. It has a base feature. So in this case, the resources, which we're able to just point a base being 2 directories up, and then also remote base if we really wanted to. And then down there, we have the patches. So what patches we want, where are we applying it to, and very versatile tool. And with this, we had the versatility of moving those duplicate files outside of the app directory and putting them up in a separate operator one. So all of these applications, we're now using the 3 same files, and we only had to change it once. And the way this new updated flow would work is the customization YAML would have the operators, say in this case, Open Liberty as a base. It would pull in those YAML files as if it was in the directory for the sake of GitOps. Send it to Customize. Customize would work its magic with patching. Send the output over to Argo, and then deploy to your cluster. Now, the benefits of this are greatly improved productivity. We reduce the setup time and deployment time. All we had to do is deploy an application. We just have to apply that one YAML, and then you're all set. Stress test running. We're also able to reduce debug time since our process was the same for each app. There are no differences per user. It's all done for you. We're also able to quickly integrate new features. With this, we're looking into adding, say, data grid support and caching. With that, we just have to expand GitOps, add more YAMLs, and then we're all set to go. This also gives us a cultural shift of collaboration. That's one of the main benefits of Git. It's built for collaboration and version control. And you see when I made an update to the app and deployed it, I didn't touch the OpenShift or Kubernetes cluster. I just did it purely through Git. So we're able to leverage Git more and more for that. And like I said before, repeatability, which is great when you're on the testing team. That's something you strive for. We're able to apply vulnerability fixes very quickly, which would have been very helpful 2 years ago with Log4j.
Yeah.
So we're ready for the next one. It also streamlined deployment for production cluster and allows quick recovery. I know we had an issue where our production cluster had to be rebuilt. With this, we just pointed it to the GitOps directory and then waited for it to come up. Some other challenges that we had is customize is a bit picky with formatting. It does not give very good errors, and it doesn't allow recursion. So a bit of learning curve there with customize, but it definitely proved to be a very powerful tool. A big challenge was how exactly do we structure our config repository? If you look online with GitOps, there's so many different ways people have done it. They have different branches, different repos. I've seen some implementations with 3 different GitOps repos, all for just one cluster. So that's a question that each individual is going to have to go about.
And we have to go through different iterations as well. Like we started with one and then have different app developers get together. Okay, how do we want to do and work within the team?
Yep, and Argo's error handling, not very good. It doesn't really tell you much. Wish that would be better, but it is what it is. And then, like with everything, there's a learning curve with GitOps process, as well as customize and Argo CD. So, in summary, we found GitOps framework to be very beneficial for our organization, gave us repeatability, consistency, and fostering more collaboration. There are multiple design decisions you'll need to make on your GitOps journey, and we suggest doing what we did, starting small and just evolving to meet your needs. And we have some more reading with articles we have and other sessions. Thank you.
That was great. Thank you. Another round for Monica and Daniel. All right. Thank you so much. Great presentation. Yeah, I used Flux, but all the managers love the UI, so then we had to switch to Argo, right? Because I just want to see a pretty picture. Show me green checkboxes, right?
Yeah.
All right, so you're in for a treat. This is my trademarked closing summary of the day. So if you've been just like snoozing the whole entire time, I don't know why you're here. Please pay attention tomorrow. We've got great sessions tomorrow, especially related to GitOps. We've got Carlos speaking about GitOps with like more advanced GitOps use cases. So now you have a little bit of a primer on GitOps, which is awesome. And then you got an advanced session tomorrow. So definitely check that out. We got John Willis tomorrow and some other awesome talks. So yeah, I'll see you tomorrow morning for that. So trademark recap. Life is an ongoing step 3, right? That's what we learned. Burnout is a human step 1, not so good. Create a personal incident response plan. That's a good idea. There's no such thing as too much tacos. Dogs can be your personal board of directors, but not cats, right? Metastable failures are tricky and elusive, spooky. Observability can be data rich, but information poor. I like that. Data rich, information poor. Hopefully DevOps Days is information rich for you. Testing is like astrology. You have to choose your sign, like crab, trophy, or pyramid. That's it. Hope is not a strategy. Always keep your receipts, right? Always keep your receipts. We need play-by-play video reviews of developers finding their third-party Coopers, right? We definitely confirmed that Pedro Pascal is a dev, confirmed. We have to assume attack is already in place all the time. We're getting attacked, you better be ready. It's always happening. Never trust, always verify, and continuously monitor. So you should probably not trust what I'm saying right now. The results of my actions are always positive. There was there was a meme there. Did you see that? I love that. I'm gonna put that somewhere. SLO is an approximation of customer trust. I really like that idea. That like an SLO is like a way to gauge your customer's trust. Frequently catastrophic is a great band name. So I don't know. I didn't check if that's a band name, but I think that's a great band name. And I was also thinking like frequently catastrophic Argo would be also a great band name. So tomorrow, after today, tomorrow you should have an app that is zero trust, has an SLO, has been crab tested, I don't know what that means, has receipts, info-rich monitoring, deployed with GitOps, developed by a community of practice to avoid burnout and earn customer trust. Oh, and is always tested in prod. Right? All right. So, and the last but not least, at the heart of DevOps is you. So thank you all for coming today. Stick around for our happy hour. It starts in just over 15 minutes. We'll start serving drinks, but we can hang out, learn more, dig into the details of all the talks today, ask questions for a bit, and then we'll see you tomorrow morning for the next sessions. Give another round of applause for all the talks today. All right, see you at drinks, especially since we have to do all these things now. Zero trust.